Welcome back to my YouTube channel, and this is the continuation of the Otto cycle. So now, we are to solve a question here. It says a petrol engine has a bore of 58 millimeter and a stroke of 82 millimeter also, and a clearance volume of 34.25 centimeters square. Determine the thermal efficiency of the petrol engine based on the air standard Otto cycle, and take the coefficient of pressure as this, the coefficient of volume as this, and the constant this as what we have here. So now that we have been given this value, we are asked to find for the thermal efficiency of the petrol engine over here. But now, based on our former research, we found out that the formula for thermal efficiency is 1 minus Q out over Q in, and can also be known as W net over Q in, which can also be known here as 1 minus T 4 minus T1 over T3 minus T2. But none of this here can be able to solve our question here, because we are not given any value of temperature here. We are only given the clearance volume, the bore, and the stroke of the engine. But now, as I mentioned earlier, first of all, we are given our clearance volume, and our clearance volume is known as V2. That is V2 from this diagram over here. V2 from the diagram over here, the clearance volume is this V2 here, V2 that is over here. And then, so we just need to find for our value of V1 and V2, so we can be able to use it to calculate our compression ratio. So now, how do we use our compression ratio to get this? How can we be able to use our compression ratio to solve this question? First of all, we have to start from this part whereby we have 1 minus T4 minus T1 over T3 minus T2. There is something called the isentropic relationship between volume and temperature, which is V1 T1 is equals to V2 here. Somewhere here that I put it, we have V raised power k minus 1 is times T is equals to constant. So therefore V1 raised power k minus 1 times T is equals to V2 raised power k minus 1 times T. So therefore we can be able to use this formula to get it. And now we know that we can be able to determine here now that um T1, if we have the relationship between the process T1 and T2, the process T1 and T2 can be written as process T1 and T2 can be written as V1 raised to the power this constant minus 1 T1 is equals to V2 raised power omega minus 1 raised power gamma minus 1, that is here V2 raised to the power gamma minus 1 times T2. So if we do our maths, and now in this particular scenario we want to make T2 the subject of the formula. If we want to make T2 the subject of the formula here, we are going to be having T2 is equals to T1 times our compression ratio, which is this. Our compression ratio V here raised to power omega gamma minus 1. So now this is what it is going to give us. And now if you are inputting this value, the same thing would also go for T3. T3 would also be equal to, we have T3 would also be equal to the same thing. Our T3 would also be equals to T4 times the compression ratio of V raised to power gamma minus 1. Gamma minus 1 here. So that is both of them. So we just impute these values over here into the denominator of this equation in which we are having this. That is this equation here, the one that we have over here. We're just going to be imputing it into that. So therefore we are going to be having this would be equals to um yeah, this would be equals to 1 minus 1 minus t4 minus t1, which is originally on top, minus t1 over, now we have our t3 and our t2, so we just put them in the denominator, and since the both of them commonly has the ratio of gamma, compression ratio v raised to power gamma minus 1, we can just put it into bracket and bring the compression ratio out. So therefore there we are going to be having in brackets t4 minus t1, then we close the brackets, and we are going to be having this to be our compression ratio v raised power gamma minus 1. So now that is what is going to be, and since now we can notice that our t4 minus t1 here, we t4 minus t1 here, and we have t4 minus t1 in the denominator also, so we can just cancel both of them out. So we can just cancel both of them out here. So we cancel both of them out, this one cancels this one. So therefore we are going to be having our final answer, we're going to be having our final answer we're going to be having our final answer here to be equals to, we're going to be having our final answer here to be equal to 1 1 minus 1 over the compression ratio of v raised to power gamma minus 1. So 1 minus compression ratio of v raised to power gamma minus 1. Yeah. One. So now this is going to be our formula for the efficiency, and this is another formula that is used commonly in the concept of efficiency here, which is our compression ratio here is equals to this. So now we can use, since we have this now, we can use this formula here our in our question in which we are given down here, that is this petrol engine question. And now that means what we need to get is our compression ratio. So we can get our compression ratio. Our compression ratio here is the total volume over the compression volume. Our compression ratio here is the total volume over the compression volume. Yeah. Our compression ratio here is total volume the total volume here over the clearance volume, that is the clearance volume. So now we can just find for our total volume, and now we know our total volume here is equals to the swept volume plus the clearance volume. So that is, we if for us to find for our swept volume now, which is our SV, we know that our swept volume would be the area times the stroke. So we just need to find for the area of our piston and the stroke so that we can be able to get our swept volume. Then add it to our clearance volume so that we can continue with our work. So now, yeah. So our swept volume here now, SV, would be equal to our swept volume here would be equal to our swept volume here would be equal to pi pi bs pi bs pi b square over 4, which is our area, by b square, where b is the diameter, then times our s, which is here. So now this is our swept volume. So we will just need to find for what is our b. Our b here is our bore, that is the bore in which we are giving here, which is 58 millimeter, and then we have our stroke here, which is 82 millimeter. Now we want to put all of them in a convenient in a convenient in a convenient unit, which is, we can use one of the clearance volume, which is in centimeter square here. So I'll just put them in centimeter square. Then I'll convert these millimeters to centimeters. We have divided by 10. So this will be 5.8. This one will be 5.8 centimeter here, and this one over here would be 8.2 centimeter. So let's go on with that. We will have this equal to pi. Our b now is 5.8. So we have in our brackets, we have 5.8, 5.8, 5.8 all square, 5.8 square divided by 4, then multiplied by our stroke, which is equals to 8.2. That is times 8.2. So if we multiply every single one of these together and they are in centimeter, everything here is going to give us 21 216.65 centimeter cube, since it is in volume. So we have everything here would be 216 point 65 centimeter cube. So this is going to be our value for our swept volume, 216.65 centimeter cube. And then we can just add this to our clearance volume. So therefore our total volume here, which is our TV, would be equals to this 216.65 216.65 216.65 plus 8.2 centimeter, which is our swept, our uh, no, our 34.25 centimeter cube, which is what we are giving here. 34.25 centimeter cube, which is what we are giving here in 34.25 centimeter cube, which is our clearance volume. So we put plus 34.25. 34.25. Then everything here divided by our clearance volume, which is also equals to 34.25. Everything here is going to give us our coefficients, our yeah, everything here is going to give us our compression ratio. So the what is on top is our total volume, then what will be under is our clearance volume. So therefore everything here is going to give us the coefficient ratio this here, which is this. So that is it for that. And if we multiply everything together here, if we add everything up together here and do it, it is going to give us, everything here is going to give us 250. What is on top would give us 250.9 over 34.25. 34.25. So and if we divide this by each other, we would get, this would give us 7.33 units. So this here would give us 7.33 as our value. So now that we have already gotten this, we can go back and solve for our cycle efficiency. We can go back and solve for our cycle efficiency here. So here we will know that our cycle efficiency is this of V would be equals to 1 minus 1 over 7.33, which is our compression ratio. 7.33 7.33 here in brackets, all raised to power uh gamma minus 1, and our gamma in the question is given as 1.4. Let us check it out. Our gamma in the question is given here as 1.4 over here, uh which is this here. So that is our gamma, and it is given as 1.4. So therefore we can come back to this, and that is 7.33 would be raised to power 1.4 1.4 1.4 minus 1 1.4 minus 1. So everything here, if we sum it up, this now is going to give us 1. This is equals to 1 minus 1 over 1 minus 1 over 2.218. So this is going to be 1 minus 1 over 2.2 1 minus 1 over 2.22. And if we sum everything up together and divide it, this is going to give us 1 minus 0.4508, which if we minus it from 1, we are going to get 0.5492. And if we put our efficiency is mostly like to be put in percentage, so we can just put our efficiency in percentage. We have this year would be equals to 54.92, 54.92%. So now this year is going to be our cycle efficiency in percentage. So now this is how to calculate for our cycle efficiency and all that stuff. We can view it from the beginning over here. We were asked to find the petroleum engine. Our petroleum engine has a bore of 58 millimeter and a stroke of 82 millimeter and a clearance volume of 34.25 centimeters square. We will also find the thermal efficiency. Our thermal efficiency, the thermal efficiency that we are going to use that is going to be valuable to us is going to be our um compression ratio, and the one that is relatable to compression ratio. So we adjusted our thermal efficiency formula to use the one that is related to compression ratio, which is over here. The one that is related to compression ratio over here, and then we went back to put it into our formula. Now we know that our compression ratio is equals to the total volume over the clearance volume, where our total volume is equals to the swept volume plus the clearance volume. And we know our swept volume is equals to pi b square over 4 times s, where our b is the bore, our s is our s is 4, our b is the ball, uh our s is the stroke. So we just impute the values over here, and we have pi 5.8 square over 4 times 8.2. We got 216.65 centimeter cube. So therefore we just imputed it, our